LANs and your WANs and your MANs and your PANs, and also your SANs. By watching this video, we will be able to describe the characteristics of a storage area network, or SAN. Our industry is inundated with TLAs, or three-letter acronyms. So we have local area networks, which are LANs, and wide area networks, those are WANs. And in this video, we're going to be talking about storage area networks, or SANs. So let's remember our scenario here. We have servers with hard drives in them that have direct connections to the motherboard. However, we want to pull those hard drives out of the servers and put them into a storage array over here. The storage array is going to house all of the hard drives in our environment, so none of the servers actually need any of their hard drives anymore. However, what happens when we pull those hard drives out? We have to have communications between the servers and the storage array that, number one, is lossless. What that means is we drop as few packets as possible because within the server, this was lossless. We didn't lose any packets, so to speak. And second of all, we want as low latency as possible. This is a concern because if we try to write to a disk and it takes a long time for that operation to happen, then that can cause problems with the applications that are trying to read and write that data. And as we can imagine, within the server, latency was no concern. We didn't have to worry about latency inside a single device. So how do we build a network that's as lossless as possible that really provides as low latency as possible as well? Well, this is the challenge of a storage area network, and this is why we have dedicated networks for storage in many cases. Now that we know the goals for SANs, it's important that we take a look at the protocols that have been developed to help meet those goals. There are two primary types of storage area networks, one that uses TCP/IP and the other one that uses a protocol that we call fiber channel, or FC. Now, IP addressing will usually use MAC address for Ethernet at layer 2, so we have our layer 3 protocol here and our layer 2 protocol here. But fiber channel and Ethernet, they're like oil and water. We cannot combine them for the most part on a single switch. If we want to combine them onto a single switch, we have to make sure that we purchase the correct switch, one that's built for fiber channel and Ethernet. Another option that we have is called fiber channel over Ethernet, which will take an Ethernet switch and run fiber channel across it. But even in this case, we don't actually use IP addresses. Now, as for IP address communication, there's one primary protocol that we typically will use, and that is iSCSI. However, there are two other protocols that we should be aware of, which are CIFS and NFS. Now, it's outside of the scope of this conversation really to delve into the differences, but we can know that CIFS and NFS, this is called file level storage, whereas iSCSI and fiber channel, these are what we call block level. What this boils down to essentially is that if we have a server trying to connect to a hard drive using block level, then it's as if this hard drive exists inside the server. That server owns that hard drive. That's what it means to have block level access. However, if we're accessing storage via a file level protocol, then in that case we don't have ownership of that hard disk. In fact, this is usually how we do file shares on the network, is allowing multiple machines to access this via these file level protocols. So just to summarize here, for IP we have iSCSI, CIFS, and NFS. And for non-IP, we have fiber channel and FCOE. These are our primary storage protocols that we're going to use in a storage area network. Now, when we build storage area networks, a key consideration is what we call storage isolation. And what that means is isolating the storage network communications from normal data-driven network communications. So let me show you what I mean here. We have a server that's going to connect via its normal data Ethernet NICs to the local area network. And this would be how oftentimes our users are going to access whatever these servers are serving up, usually applications or data. Then if we want that server to have storage communication, they will typically connect via the storage area network, and this is where it can communicate to the storage arrays down here. Now, if this right here is what we call an air gap, meaning that we have switches up here and we have switches down here, so there's separate isolated switches. Well, now if there's a disturbance in the LAN, let's say we have a spanning tree failure or some major issue, well, even though the users can't access the servers did not lose access to the storage. That's a very good thing. And by the way, if we build the storage area network with fiber channel or FCOE, this is typically how we have to build it. Because again, fiber channel and Ethernet, they're like oil and water. And unless we have very special switches, we can't actually mix those two. And so by purchasing fiber channel switches, we actually do get this storage isolation, which is very beneficial to us. However, now let's say we're using iSCSI, and we go to our bosses and we say, hey, we want dedicated switches to run iSCSI. So we want to make these, even though they're Ethernet switches, for iSCSI, right, we're going to be running TCP/IP on them, we can still isolate them by deploying separate switches that connect to the storage arrays. But our boss comes back and says, hey, well, can't we just use these switches? We already own Ethernet switches, so let's just use these. And that way we save a bunch of money. Okay, well, I guess we could do that, right? And so we do that, and we connect our storage now up here. And so now our storage is hanging off the LAN in the same way our users are. Well, let's talk about that problem again. What happens if that LAN goes down? Well, the users have lost access, but now the servers have actually lost access to the storage as well. And if we think about that scenario where we have a server or PC with a hard drive inside, I mean, imagine ripping this hard drive out. Servers and PCs do not do well when hard drives get ripped out of them mid-operation. And so this can cause a lot of corruption and a lot of issues. Oftentimes we'll have to pull from backups in order to recover from this scenario. So that's why it's always recommended, whether we go iSCSI or Fiber Channel or FCOE, it doesn't matter, have storage isolation, have a separate storage area network to make sure that it stays online in the event of a LAN failure. So, now you are able to describe the characteristics of a storage area network. I hope this has been informative.